everyone, and thank you very much for being here. Let's talk about winning with AI. We all know, don't we, that there is incredible excitement about the potential of AI and machine learning to transform the industries that we work in and that we serve. And of course, we have all seen, how could we miss them, the breathless estimates of the potential economic impact of the widespread deployment of AI and machine learning. One recent estimate from PwC estimates the potential economic contribution of AI and machine learning at $15.7 trillion annually. And that is more than the combined output of China and India. But of course, as the old Danish proverb has it, prediction is difficult, especially about the future. And even those consultancies acknowledge that there is a very wide margin of uncertainty on those estimates of the economic impact of AI and machine learning. What we do know for certain, though, is that the market capitalization of the big five technology firms increased by $2 trillion this year on the back of that excitement about the potential of AI and machine learning. And The Economist makes that, in round numbers, approximately $300 to $400 billion of increased annual revenues that the market is expecting the big five to deliver from AI and machine learning. Of course, the markets have also been pretty volatile recently, with at least some analysts suggesting that that reflects increased investor concern about the potential of AI and machine learning to drive return on investment over the short term. But if we stick to what we know, we do know that AI and machine learning adoption rates are still fairly low. The US Census Bureau puts adoption rates at 5%. The Canadian number is 6%. In the UK, official estimates of adoption are more optimistic at 20%. But honestly, the different survey methodologies mean that directly comparing those numbers is pretty risky. As a patriotic Brit, I'd love to believe that the UK is streaking ahead of the US in the adoption of AI and machine learning, but honestly, I'm not so sure that's really the case. What we do also know, though, is that a very high proportion of AI and machine learning projects fail. In fact, according to one recent study from the Rand Corporation, 80% of AI projects fail. And that is a sobering statistic for many of us sat in this room embarking on AI and machine learning projects of our own, under pressure from our boards and from our executives to deliver meaningful improvements in business outcomes. Look around you. The statistics suggest that on the current trajectory, 4 out of 5 of us are going to come up short in meeting those expectations. The same RAND study identified 5 root causes at the heart of most AI and machine learning failures. Miscommunication between business and data science teams and a lack of understanding of the business problem and the underlying business context. Insufficient or inadequate data compromising the process of model training. What we sometimes refer to in the industry as shiny object syndrome, a desire to use the latest and greatest technology, irrespective of whether it's really the best fit for the problem at hand. Over-rotating on the algorithms, focusing more on the process and the infrastructure associated with model training, and less on the infrastructure and the process associated with deployment and operationalization of AI and machine learning at scale. And lastly, sometimes being too ambitious for the technology, assuming that it can automatically solve all of the hardest problems in our business. So for the rest of this presentation today, we're going to double-click on those root causes. We're going to discuss how we can load the dice to maximize the chances that our own AI and machine learning projects are successful. And we'll also showcase some examples of projects that have successfully mitigated some of those failure modes. This is our agenda. We'll talk about the importance of an AI-ready data foundation and briefly touch on how to create one. We'll ask if we really do have to choose between tried and tested production-ready technologies that scale or newer technologies that might enable us to innovate faster. We'll touch on deployment and operationalization, and we'll discuss this magic wand issue. How do we balance the need to be ambitious for the technology and its applications with our desire to bring downward pressure to bear on those failure rates? And then finally, we'll briefly discuss the AI and machine learning lifecycle to try and get to the bottom of this observation that one of the leading causes of AI and machine learning failures is miscommunication between business stakeholders and data science teams. An AI-ready data foundation is a prerequisite to successful AI and machine learning initiatives. The RAND analysis is absolutely explicit on this point, with more than half of the participants surveyed by RAND citing data issues as a significant contributory factor to the failure of AI and machine learning. So if we want to load the dice in our favor, we need to start by getting the data foundation right. In some companies, honestly, this is partly an organizational issue. Because models are sexy and data are plumbing, we often incentivize people to pursue careers, the best talent, to pursue careers in data science rather than in data engineering. But in our experience, this is also a question and an issue of data architecture. Because many organizations today take a one pipeline per process approach to machine learning. That means that we go all the way back to the data lake, or even worse, all the way back to source systems over and over again to get more or less the same data, to wrangle it to create very similar features, to train the same or similar models in adjacent spaces. And that one pipeline per process approach results in data silos and rapidly accumulating technical debt. By contrast, best practice is increasingly to curate the features of proven predictive value in an enterprise feature store to enable reuse for training and scoring other models in the same and similar domains. And this approach is enabling leading organizations to dramatically improve analytic time to market and data scientist productivity. Anecdotally, those organizations also tell us that they improve model quality this way because the very act of curating features encourages the team to think about whether they are creating the right features. And their frequent reuse means that any issues with those features are discovered more quickly than would otherwise be the case, ensuring that the features have been built right too. Now, the central promise of a feature store is reuse. Reuse of features across multiple models and reuse of features to support exploration and discovery, model training, and model scoring. But the quote on this slide tells you that the expectation in the market is that organizations will typically need to deploy multiple technologies to build an enterprise feature store that can support the end-to-end AI and machine learning lifecycle. Many of you in this room are enterprise architects, and you know that multiple data stores means more cost, more complexity, and what Larry Ellison used to describe as the gift that keeps on giving, more systems integration. By contrast, the Vantage secret sauce, smart scaling, advanced indexing, the industry's best cost-based optimizer, the industry's leading mixed workload management, means that Teradata customers can support feature engineering, model training, batch scoring, and near real-time inferencing all on the same platform and all at the same time. The same platform that in many cases is already supporting all of the production reporting. For example, a major global airline manages customer loyalty data in Vantage, with ClearScape being used to create a feature store that enables the training and scoring of models that predict and anticipate customer wants and needs. Crucially, Teradata's open and connected strategy enables those features to be written to open file and table formats so that they can be consumed by multiple downstream technologies, enabling the airline to have the flexibility to use the right tool for the right job. Vantage was the clear choice to generate the thousands of features from millions of observations that are used across the business. And when we asked the customer about that, they said a couple of things that I think speak to the value of a feature store in general, but also to the value of Teradata as a feature store in particular. Building our feature store enables the data scientists to focus on data science. And why would we create the feature store anywhere else? That's where the data is, it performs, and it's reliable. Our next example of the power of a feature store approach is from retail finance. The bank concerned in this example has a complex management structure and needs to aggregate data from multiple subsidiaries in order to meet its regulatory reporting requirements. Missing and inaccurate data can compromise that process and end man days of additional effort at the end of each reporting cycle on each month, diverting valuable SMEs for more important work. And to address that challenge, the bank had developed a rules-based system to try and identify bad data prior to consolidation. The system generated so many false positives that it overwhelmed the experts who needed to follow up on those alerts. An AI-based solution running on Vantage has dramatically improved the process of anomaly detection with the use of in-database feature engineering accelerating monthly processing. And furthermore, by combining our open source Python feature store library with a data lab approach, the organization was able to quickly and efficiently run multiple experiments and to rapidly identify the most accurate multi-model approach to identifying bad data. Okay, let's discuss one of the other root causes identified by Rand. AI projects that fail because the organization concerned is determined to use the latest and greatest technology at the expense of focusing on the business problem and irrespective of the suitability of that technology for production deployment. If you're familiar with the film Skyfall, you'll probably remember a frosty first meeting between Bond and Q, when Q tells Bond that age is no guarantee of efficiency, and Bond tells Q that youth is no guarantee of innovation. Where AI and ML projects are concerned, is that really the choice in front of us? Are we really forced to choose between tried and tested production technologies that can scale to meet production service level goals, or new technologies that can enable us to innovate faster? Well, our answer, as you heard from Steve and Hillary yesterday, and the logic of our open and connected strategy, is a resounding no. Yes, ClearScape does deliver highly optimized in-engine analytic functions that support the end-to-end AI and machine learning lifecycle. But we give equal billing to R and Python as well as SQL, and we work very hard on our integrations with the leading AI/ML workbench providers. And crucially, we continue to invest in our bring your own analytics and our bring your own model capabilities. For us, bring your own analytics is about enabling customers to leverage open source libraries with Teradata, both in database and adjacent to the database with our open analytics framework. And bring your own model is about enabling our customers to score models in Vantage at scale and at speed, regardless of where they were trained and with which technology. Our open and connected strategy is a best of both worlds approach. You get the power and performance of Teradata with language, library, and tool of choice flexibility. And let me give you some examples of what that looks like in practice. The complex industrial pumps that move oil through major pipelines are safety critical systems. So avoiding unplanned maintenance outages is crucial. And as the manufacturer's business models increasingly move to OpEx-based business models, it's also vital for the company's top line. This company's technology provider had trained an accurate predictive model based on an LSTM recurrent neural network running on a Spark and Python-based technology stack. Now, some of you will know LSTM stands for long short-term memory. It's a type of recurrent neural network, a form of deep learning that is extremely accurate for classification problems like this. However, this solution scaled and performed poorly. By converting the Spark-based feature engineering pipelines to SQL running on Vantage, we were able to load and process complex historical data 6 times faster than the prior solution. And by training and scoring multiple per segment models, Python-based models in database, we were able to improve both predictive accuracy and to parallelize that process. In fact, scoring on Teradata ran 10x faster than the Spark-based alternative. And better predictions available much more quickly means more uptime. Now, we've already briefly discussed bring your own model, so I promise you I won't drain this busy slide. But for those of you that haven't used bring your own model yet, it enables us to import models that have been serialized using leading model export formats like PMML, Mojo, and Onyx, so that they can be scored on Teradata. Because Teradata is where the data are, because Teradata is a rock-solid mission-critical platform, and because we can typically score models more performantly and at much lower cost than the competition. As Hillary told you yesterday, by deploying pre-trained open-source language models from Hugging Face directly in database, a large US bank has been able to understand the voice of customer across multiple channels. The embedding models are imported from Hugging Face using that Bring Your Own Model framework. They're executed in database on CPU infrastructure at scale and at speed. We'll talk some more about that in just a moment. High performance in database vector distance calculation enables semantic search and retrieval augmented generation pipelines. And in plain English, what that means is that email and voice communications can be clustered so that we can enable, for example, potential customer complaints and examples of mis-selling. The resulting powerful signals of customer intent can be easily combined with all of the other data that we have about customers that's managed on the enterprise data warehouse. And all of this is achieved without sensitive data having to cross the corporate firewall, even as prompts. By the way, the business value of the first 3 use cases in this bank is estimated by the bank, not by us, at $140 million per annum. Now, some of you are going to be scratching your heads at this point, wondering how this solution works and how it works on Teradata. I mean, don't you need GPU infrastructure to score language models? Well, language models come in different shapes and sizes. There are the trillion parameter large language models that can rewrite your email in the style of a Shakespeare sonnet. And there are 150 million task-specific language models for things like topic detection, entity resolution, sentiment analysis, etc., etc. And the magic of Teradata means that we can parallelize the execution of those task-specific language models in database to generate vector embeddings from inbound customer communications. If you've done any statistics, you can think about those vector embeddings as like principal component analysis on steroids. And what they enable us to do is to cluster those communications so that we can perform incredibly powerful similarity searches, even for documents that don't contain obvious keywords. Analyzing complex, multi-structured interaction data like inbound emails for rich signals of customer intent is the superpower of this new generation of AI technologies. And if you want to understand more about how you can use these technologies running on Vantage to radically improve customer experience today, then I really encourage you to come and see Gary Class's presentation in the AI track later today. Now, crucially, these workloads don't just run in Vantage, they run really well in Vantage. This chart summarizes some of our early customer benchmarking results. Our tests show that even a small 2-node Teradata system can match the inferencing performance of a pretty decent GPU. Now, these results are obviously sensitive to the size and the complexity of the model that you're scoring and the embeddings that it is creating, so your mileage will vary. But if your assumption is that you have to have GPU infrastructure in order to run these workloads, then you need to come by the Teradata booth later today, because we can show you how you can get started with Gen AI for CX right now without any additional investment. Scalable and performant inferencing of those task-specific language models via BYOM is what internally at Teradata we sometimes refer to as Gen AI design pattern number 1. It's a great fit for those task-specific models in the 100 million parameter range. Our Lake customers can leverage our new Bring Your Own large language model capability to score more complex models on analytic compute clusters running on GPUs. And ultimately, that will also give us the ability to help you fine-tune models for your particular application-specific requirements. That's design pattern number 2 on this slide. Now, there are times when only a trillion parameter language model will do. Unlike some of our competitors, we have no plans to build a foundation model of our own. Honestly, we think that's a vanity project. There are really good foundation models out there already from our partners, and our job is to help you integrate with those technologies so that you can use the data managed by Vantage to support prompt engineering and the development of policy layers. And we'll shortly have an even richer set of APIs for robust integration with the foundation models provided by our CSP partners. And that's design pattern number 3 on this slide. Steve told you yesterday that we would meet you where you are on your data and analytic journey, and this is that principle in action. A range of options to give you the flexibility that you need to build the different solutions that your business requires. Now, the RAND study highlights that organizations often underthink AI and machine learning deployment. And getting that right requires us to be clear about what we actually mean by deployment in the first place. Using AI and machine learning to generate signals that help us understand the business is fun and it's intellectually satisfying. But we don't create any business value by simply running a model and updating a table of predictions. If we want to change the way we do business, we need to continuously push those signals into operational applications, processes, and workflows so that we can actually take action on them. Connecting models to workflows and applications requires us to manage how and where those models are deployed. And that's why we continue to invest in the ModelOps toolset, as Dan explained yesterday. ModelOps enables end-to-end monitoring and management of AI and machine learning models so that Teradata customers can quickly accelerate, scale, and optimize their deployment. ModelOps can be used by all of the team involved in managing the model lifecycle. It has different interfaces for those different roles and user personas. Put simply, ModelOps means that you can deploy more models more quickly. This example speaks to that. Prior to using ClearScape Analytics, the customer described on this slide had stalled in their attempt to drive business value from AI and machine learning. They struggled with scaling machine learning to production. They struggled with the challenge of governing and maintaining the models that had already been built and delivered to production. And they had hit a wall, a model plateau. They could not increase the productivity of the data science team any further, and that meant that they couldn't build more models for the business without increasing costs and expanding the size of that team. Leveraging ClearScape and ModelOps was a game changer for this organization, as the numbers on this slide demonstrate. Now, Rand suggests that one of the reasons that AI and machine learning projects fail is because the technology is sometimes applied to problems that are just too difficult for AI to solve. If you were here last year, and I know that some of you were, you'll remember that Steve's explanation that we think about AI and ML-driven strategic transformation with 3 horizons. Horizon 1 is the optimization of internal operations, when we are applying AI and machine learning to demand forecasting, churn and propensity modeling, price optimization, predictive maintenance. That's a Horizon 1 concern. Horizon 2 is about using AI to improve products and services, or to radically rethink our products and services. A Gen AI chatbot to improve the mortgage application process is a good example of a Horizon 2 application of the technology. Horizon 3 is where things get really interesting. Some of you remember when Unilever spoke at this event last year, for example. They imagined a future in which bots from the retailers would dynamically and continuously negotiate range, supply, and pricing with bots from the suppliers. In that future, the supplier with the best bot, able to match sales margin against available capacity, could dramatically disrupt and upend the whole marketplace. So earlier this year, I had the opportunity to present to a room full of chief data officers, and I used this framework to ask them to classify their own AI and machine learning initiatives. I asked them, are your AI and machine learning initiatives mostly about Horizon 1, mostly about improving internal operations? Are they mostly about Horizon 2, thinking about improving products and services and developing new products and services? Or are you really ambitious for the technology? Are you trying to rethink your whole operation? And the results probably won't surprise you very much, because in our experience, the most successful organizations are taking a portfolio management approach to their AI and machine learning initiatives. They are ambitious for the technology, and they do include in their portfolio at least some projects which stretch the boundaries. But they also continue to focus on what we might call the bread and butter use cases. Use cases that in many cases we've been discussing for decades: churn and propensity modeling, fraud detection, predicted customer lifetime value, etc., etc., etc. In fact, I think that one of those recent economic impact studies that we mentioned at the start of this presentation, this one from McKinsey, makes this point very elegantly. This study suggests that the value of AI and analytics in banking alone will soon reach $1 trillion globally, but that 2/3 of that value will be delivered by what they refer to as traditional AI and analytics, regular machine learning, if you will, rather than generative AI. And I think that speaks to the importance of this portfolio management approach. We are not going to deep learn everything. What matters is what works. Adopt the new technologies where they make sense and where they can add value, but remember that the best model is always, always, always the simplest model that's sufficiently accurate for your use case. Lastly, the RAND study suggests that the single leading cause of AI and machine learning failures is a lack of understanding about the business problem that we are trying to solve. And to understand why business leaders and data science teams sometimes speak past each other, I think it's useful to think about the AI and machine learning lifecycle. One of the very first attempts to document and codify the AI and machine learning lifecycle is represented on this slide. And this is the so-called CRISP-DM model, the cross-industry standard for data mining to its friends. It dates back to 1996, and in fact, Teradata is one of the co-authors. One of the key insights that CRISP is attempting to communicate is that the process of developing AI and machine learning models is iterative and incremental. Successful projects don't start with the technology, they don't even start with the data. They start with a thorough understanding of the business problem, and they recognize that the only thing that's certain in this endeavor is that that understanding of the business chain problem will change as the project evolves and unfolds. And what that means is that the software development methodologies, even the agile ones, can be a poor fit for AI and machine learning projects, especially at the start of the process. The RAND report is absolutely explicit about this, but in fact that's not a particularly new insight, but rather one that each new generation of data scientists and their managers has to learn over and over again. The practical consequence for all of us is that understanding the business context is critical. Business leaders cannot afford to be hands-off about AI and machine learning projects, and successful data science teams are very often embedded in the business. Okay, it's my boss next, so I need to bring this home. RAND identify 5 major failures, root causes of AI and machine learning projects. We can mitigate the risk of miscommunication between business leaders and data science teams by starting with the end in mind, embedding data scientists in the business, and recognizing and understanding that we will need to iterate and explore. We can address data-driven failures by elevating the prestige of data engineering in our organizations and, crucially, by adopting a feature store approach. It's a false choice, this choice between tried and tested and innovative. We need to prefer open and connected technologies that enable both and ways of working. We tend to over-rotate on the algorithm, to focus too much on the process of model training and not enough time on questions of deployment. And our answer to that is investment in operationalization at scale via bring your own model and our model ops approaches. And lastly, there's a tendency for some of our business leaders to regard AI as a magic wand, and we can address that challenge by adopting a portfolio management approach. Take more roof shots than moon shots at the start of your AI journey and increase your ambition levels as your organizational maturity increases. As we've touched on briefly during this presentation, we believe that we're well positioned to help you with all of these challenges. We can provide scale and performant Gen AI for CX on-prem and in the cloud. We can help you operationalize models at scale regardless of where they have been trained. We can dramatically improve data scientist productivity and the time to market for new analytics with a feature store. We can enable any tool, any flexibility without the associated technical debt that results from multiple data stores. And we can offload expensive and poorly performing Spark and Databricks workloads. So let us help you load the dice. Let us help you build an AI-ready trusted data foundation. Let us help you with signal detection at scale and at speed. And let us help you run your AI and ML workloads better, faster, and cheaper. Thank you very much for your time and attention, and enjoy the rest of your conference.